In this episode of openFrameworks superBasics, we're mucking around with sound and we build ourselves a random synthesizer drum machine that does drunken walk through volume, pan, and sample speed. This time on openFrameworks superBasics, we're looking at audio. I've got some headphones and we're going to make some really dirty electronic noises and play about with them. So the first thing that I'm going to do is I'm going to make a new project. So I'm going to go to my project generator and I'm going to call this Dirty-Electro and just generate a new project. And in openFrameworks, that'll open up, and again, as usual, I'm interested in my header file, the .h file, and the .cpp file. To tidy stuff up, I'm going to get rid of a bunch of things because I'm not going to be clicking the mouse and dragging it around. So I'm just going to keep the void setup draw routine and get rid of these others. So I get rid of the function definitions that are in the header file that say this is what our program can be made of, and I get rid of how the functions work in the CPP file, which explains how the functions do the particular thing. So it's much simpler now. And I want to load some sounds. And the first thing that I want to do is go and find a sound. So I'm going to put some headphones in. I've got a couple of samples I've been mucking around with before. In the openFrameworks apps, my apps folder, I've got my new Dirty-Electro project, and if I open that up, I can see the bin folder, or the binary folder, where my application will be built, and the data folder. And I need to put some sound samples in there. I can put them anywhere that I like, as long as I put the correct file path, but if I just put them in the data folder, that's the first place my openFrameworks application will look. So I've got a bunch of samples that I've used for another project here. And let's have a listen to a couple. Lots of different electro sounds. Oh, some nice dirty electronic. I'm just going to grab super simple, kind of dry electronic kit, and I can just copy that sample and I'm going to put it into the data folder here. So if I select that and grab its name as sample1.aif, and this will play WAV files and a bunch of different file types as well, but WAV and AIF are probably the most common. So I go to my project now. The first thing that I want to do is make a sound player to play this sound. The simplest thing that we can do is to play samples. So I can say OF sound player, and I'm going to give this a really simple name, sound. And I can make as many objects as I like, and I can manipulate these objects. So making this new object, this sound object called sound, allows me to then, in my setup, say sound dot load. And now I need to give it a file path and file name. And because I put my sample into the data folder, the bin data, openFrameworks will look there first. So I can just give it the name of a sound to load. What I can do is straight away, I can just issue, as soon as a sound is loaded into the setup function, sound.play. And now that sound will play the minute the application starts. It'll load the sound into the sound object, the sound sample file, and then play it. Great. So it plays, but it only plays once. Now, every time I issue the play command, it'll start playing again. So I could say in my key pressed case spacebar, sound.play. And because we declared and we made the sound object, instantiated the sound object in the header file, all the functions can see it. So now if you press the spacebar, it's going to issue this sound.play command. So it'll load, compile, run the first time, play me the sound. So every time I hit the spacebar, it'll play the sound file. But that gives us a particular thing. Every time I hit the spacebar, it'll play the sound again from the beginning. If I just wanted it to loop, there's a bunch of things that I can say that sound sound play objects have attributes for. So I could say sound.set loop, and I can set the loop to be true or false. The initial starting point, the default, is that the looping is false, i.e. it doesn't loop. But if I say true in my setup, so I load the sound, and I'm just going to remove the play from there. So setup, load the sound, sample into the sound object, set the loop to be true, and when I hit sound play, it's going to start playing, and it'll loop. So silence, plays, great. So far, so kind of slightly electronic and boring. It loops. What I could do is I can poll what the speed of it is. And if it's more than 0, i.e. it's playing, because that speed is an attribute, then I could tell it to stop. I can also do awesome things like sound set speed. So this time I'm going to set the speed to be 0.5. Volume is another thing that a sound can have, and panning, left to right stereo panning. And most of these attributes go between 0 and 1. So 0.5 is half the speed, or 0.5 will be half the volume. Panning, interestingly, goes from -1 to 1, so 0 is center. And then 1 is right and -1 is left, I believe. Double check the documentation link down below. So now I load my sound, set it to loop, set the speed to be 0.5, and we're going to have some crunchy, dirty electro. Cool. That's kind of getting somewhere. We're doing something interesting. It would be really good if I could control that a bit more. So what I can do is I'm going to make another case statement here and say case, and use the plus button. And just in case I'm not holding the shift key on my keyboard, I can also make multiple case statements to say case equals, set the speed to be whatever the speed is, because we can get the speed plus 0.1 and set the speed to that. So it's just going to increase it by 0.1. And then I'm going to tidy that up. There should be a break statement after that. Tidy this code up a bit. I'm going to copy and paste this to say if I hit the hyphen or the minus key, or the underscore key, I want it to be set the speed minus 0.1. So we've got these two things. Hit the plus key, gets the speed of the sound, the current playing speed, adds 0.1 to it and sets it to that. The same minus 0.1. So now it'll start off load my sound, set the looping to be true, set the play speed to be 0.5, and then it'll start playing when I hit the space bar. And when I use the up key, the plus key, it'll increase in speed. When I hit the minus key, it'll decrease in speed. So let's see what we got. Away we go. Okay, so far so good. Hit the plus key a couple of times. Awesome. That's just a beautiful, I love that electronic, broken, stretched out noise. Hopefully you've got some bass, or listen to it through headphones if you're going to do audio. Otherwise, you know, out of laptop speakers and stuff like that, you can hardly hear stuff. And if you're watching on your phone, put headphones in. Now, what we can also do is we can set the volume and we can set the pan left or right. So I can set all of these different things. One of the things that I can also do is set the speed to be negative. So it starts to play backwards. So let's try that now. I'm going to set the speed to be minus 1.0. So it should play this drum sample backwards at full speed. I really like that. And now I can speed it up and slow it down from there. So if I increase the speed, it's going to go from a minus to a 0, and then positive, and it's playing forwards. And I can do the same and decrease and run it. So I can set the speed to be forwards and backwards to multiples of the normal speed, and I can set the pan and I can set the volume. What I want to do is bring all of those things together, and I can play multiple sounds as well. And I've got different functions where I can ask the sound, how far through the sound length are you? So if I can set a sound to be playing, I can say, you know, when it's 50%, do this. When it's 70%, do that. So I just put together a dumb thing. There's a particular piece of work that I wanted to work on. There's a sound piece that I've been meaning to make for quite a long time, which I'm going to do a small feature on. But there's some issues because I'm using a piece of sample from somewhere else. These samples I've made. And there's other free samples that I've got rights to play here, but there are certain things that YouTube kind of goes, no, we think that sounds similar too. But I want to show you a piece that's kind of fun and brings in randomness. You can make your own messed up sound synthesizer. I've made this new project, and it should be using a particular sample from a David Bowie track called Young Americans, and there's this loop where it says, and I'll put the loop if I can in here, just going to cut it, possibly from a karaoke version, but it basically says, live for just these 20 years. Should we die for the 50 more here? And it's this earworm, and it's been bugging me for years, and I've done multiple versions of it in quadraphonic where you have a whole room and the sound just drifts in this earworm, looping, sort of repetitively, can't get rid of it. I think earworm is a German expression. Somebody will correct me on that. So I wanted to do that piece, but I'm going to do it with some different audio. And what I've got in my header file is I've got a sound player object, again called sound, and I've made a new kind of object. And rather than using a floating point number or an integer, because what I want to do is I want to keep track of the pan from left to right and the volume going up and down and the speed that a sound plays. So I've got these three things that I want to remember about a sound. And I could use three floating point numbers, and I could name them sound and speed and so on. And that's sort of kind of easy. But what I can also do is I can make a new kind of object that's got three parts to it, which is an OF point object. And that can have an X and a Y point inside it. So you can just say location, and location X will be the X value, location Y will be the Y value inside this one object. And these are going to have the X and Y and Z as volume and pan and speed. So I've made a new target, an old target, and then I just made a floating point number called counter and one called max counter. So what I'm going to do is I'm going to say, get my sound. I'm going to use this lens cap as an example. Get my sound, and I want it to be here in an XY plane. So left and right is my pan, and up and down is my volume, and bigger and smaller of my dot is going to be the speed that my sound plays at. And I'm going to say, start here, then choose a random location to go to, which is going to be a random speed and a random volume and a random pan. And it'll move to that. And when it gets there, it's going to choose another random speed, random volume, and random pan, and move to that over a period of time. And I'm going to count how long that takes by using a counter. So max counter is going to be this value to say, how many steps does it take to get to my new sound, my left and right pan, volume, and speed? And where are we in that journey? So I'm going to keep counting with the counter, and the max counter will say how many steps I want to get to. So that's how it's going to work. And in my CPP file, the first thing that I'm going to do is I'm going to load a sound. And I've got a folder called Dirty Electronic Samples, and I'm going to choose sample 7. So the Dirty Electronic samples are all here. So this is my project called 20 years. Here's my data folder. Let's see if I can play this.
Live for just these 20 years. Do we have to die for the 50 more?
That's what it's supposed to sound like. This is it slowed down.
Live for just these 20 years. Do we have to die for the 50 more?
And that loops, and that's beautiful. So I've got this folder full of Dirty Electronic samples. I'm going to load number 7. I'm going to set the loop to be true, and I'm going to straight away have the sound start playing. And then just for good measure, I'll set the background to be black and use OFSet color to be white. And I'm going to take my counter, which is initializing or counting how far am I in my journey towards my destination pan, volume, and speed. Start that at 0, and I'm going to say the max counter, this is how many steps, is going to be 1,000. I'm actually going to say 1,000.0 to make sure that it knows I'm in a floating point number and not an integer. And I'm going to start out, and I've got these two OF point variables or objects, and they can have 3 values inside, an X and a Y and a Z. And the first one, the old target, I'm going to use set to say, make the 3 values inside this 0, 0, 0. So we start out at a volume of 0, a pan of 0, and a speed of 0. And I'm going to say my target, set that to be for the X, which is across, is going to be from -1 to +1. So I could, actually we'll tidy that up. I can say, make a random number between -1 and 1.0. And then that will generate me my random pan that is my target. And then I'm going to say in the Y position, this is going to be my random volume between 0 and 1.0. So make me a random number for that. And then the random speed, what I can do is say, make me a random number between 0 and 0.5. And I always want it to have a minimum of 0.5. Otherwise, at playing a sample at 0.1, like a tenth of the speed, is so slow, a lot of the stuff just starts to break down. So I wanted to have a minimum of 0.5, and I could say, actually tidy this up, 0.5 to 1.0. So with OF random, I can give it one value. It'll be between 0 and this value, or two values between 0.5 and 1.0. So I've got my two start points, or I got my start point at 0, and then my target of these random volume, speed, and pan. And then in the update, I'm going to say if my counter has counted up all the way to my max counter, which we saw was 1,000, then we're at this location, which was the new target that we're going to, volume and pan and so on. Put that into the old target and make new values for target. So have a place that we start from, decide we want to go here, go there, and when we get there, make a new place we want to go. Go there. When we get there, make a new place we want to go. Go there. When we get there, make a new place like this, so on. So it makes a new target using, I'm going to copy this improved, set a random value from minus 1.0 to 1.0 for our pan, between left and right, and then for our speed from 0.5 to 1.0, and then make the counter reset to be 0. And I'm just using the console out command here as a debug. Actually, I'm going to tidy up, delete that. Otherwise, so if the counter is equal to the max counter, we've got to our target where we want it to go, then we make a new target and start on the journey to go there and reset the counter. Otherwise, this is what's happening most of the time, we're saying set a floating point number called pan to B, and we're using this amazing command called lerp, linear interpolation. And it says, it's a way, a bit like the map, to say, here's a set of values and here's another set of values. Can you work out between these two what I need? And what we're able to do is to say, here's our start point, here's our end point. We're going to take 50 steps between them. What will the value be when I'm halfway? Or what will the value be when I'm 3/4 of the way? So I could say, I'm going to start at 90 and I want to end up at 400. What's halfway between them? What's 3/4 of the way between them? So with lerp, it does linear interpolation. It interpolates between two numbers, depending upon how far you are percentage-wise between them. So it wants your start point, your end point, and the percentage you are between those, which is really, really cool. We saw a bit like this when we were drawing the lines and working out what's 50% of the way through a line. So with lerp, we give it our start number, which is the x position of our start, our end number, which is the x position of our end, and then how far we are through our journey between them. And we want there to be max counter steps, in this case 1,000, and we divide how far we are through on the counter by the maximum amount of steps, and that'll give us a percentage of how far are we to our 1,000 steps. And that gives us an output, and we use sound set pan to set it to that output. So a bit weird. Use linear interpolation, OF lerp, our start point, our end point, and then how far we are through that journey from one to the other, and we get a number spat out, which is awesome. And we do exactly the same for the volume and for the speed, and we use sound set pan, give it a value, sound set volume, sound set speed, and then we say counter plus plus, because we've done one loop in this 1,000 steps we're going to make. And we can go off from there. I'm just going to comment 2 lines out here, and to check where we are, I'm going to use OF draw bitmap string highlight, which draws a bitmap string but in a dark block, so it's highlighted against the background. And I'm going to say print out the word pan and then get the amount of the pan and turn it into a string. Print out the word volume and get sound.getVolume, get the amount of the volume, turn that into a string, and then add on the word speed and use sound get speed, turn that into a string, and then print it out at location 20, 20. So it just wants, what do you want me to print and where do you want it? And we're grabbing this information and assembling it in kind of real time of get me the volume, get me the pan, and so on, and put in these words in between so we have something intelligible. And now, when I play this, it compiles. No, it doesn't. It fails. I've made a spelling mistake somewhere. Yeah, need an extra bracket. So I compile this now. It's going to make a sound object, load the sound object, so I've chosen this big warbly synth line, which is sample 7, which should sound like this. Maybe I'll go back to our drum pattern. Yeah, okay, so sample 3. We'll swap this for sample 3 at the beginning. And let's see what happens when we take up drum pattern and start doing this random walk thing to it. So it compiles. Oh, that's nice. That's really nice. You can hear it slowly speeding up. And if you've got headphones on, you can hear the pan and the slow increase in volume. And our debug at the top. Here it's speeding up and decreasing in volume and panning all the way over to one side. So that's great. It's doing a bunch of interesting things, but it's difficult to visualize quite what's going on, especially if you're watching this without headphones in. So we can get all this information. And the first thing that I'd like to do is just say, let's use OF drawline, which we've seen before, and show on this square 2D plane, X and Y, which is going to represent our pan left and right and our volume up and down, let's show where we're going. So we can get the old target and we get the first value from it by saying old target. This is the object with 3 numbers in. Old target.x will give us our first number, old target.y will give us our second number, old target.z gives us our third number. So we can get the old target, and because it's a pan, it goes from -1 to +1. We want to add 1 to it and times it by the width of the screen. So we've now got a number between 0 and 2. And if we multiply that by half the width of the screen, it'll give us a position left and right for our pan, with 0 pan being the middle of the screen. And we're going to do, for the Y, we know that's between 0 and 1 for the volume. So we'll just multiply it by the height of the screen, and it'll go from the bottom of the screen up to the top of the screen. And that's our start point for our line. And we do exactly the same to get our end point for the line. It gives us x1, y1, x2, y2 for the beginning and end of our line. So this is the line that the sound's going to follow. hear it building up again because we always start at 0, 0, 0. When it gets to the end, 1,000 steps, which is about 30 seconds, it's going to choose a new line and travel along that. But what I'd like to do is see where are we. So I'm going to say, draw a circle and use exactly the same routine, but I need to get where we are now, not our start point and our target. So I can use draw a circle and get the pan +1 divided by half the width, which will give me an XY position, and get the volume times the height, which will give us our height of where we are if we're moving around using the screen as our 2D grid. And then I want to make the size of the circle, the radius, equivalent to the speed. So I'm going to say get the speed, which can, with that speed, we set it to be 0.5 to 1, so half speed to full speed. And I'm just going to times that by 50. So it'll be from 25 to 50 pixels in size. And if I play this now, I'll run this and compile. What it should give us is, here's our sample coming, and as it gets bigger and bigger and bigger, that means it's speeding up. And when it gets to the end of the line, it'll choose a new line, and the dot shows us where we are on this journey with pan left and right, volume up and down. Now it's taken a very short walk. When it gets there, it'll choose another walk randomly. This is a longer walk, so you can see it's traveling faster as it does this linear interpolation between our start point and our end point. But I'm a bit bored with that. I want it to go faster. And because I didn't fix the maximum amount, I put it into a variable at the top, I can set my max counter, say, to be 300.0. So it'll only do 300 steps, which if we're running at 30 frames a second, will be 10 seconds. Running at 60 frames a second will be 5 seconds. So now it'll run and it'll choose a line much faster. So here we go. It's flying across the screen. Nice. But what I'd like to do is try with some different things. So I can use sample number 7, which we were playing with before, which is this kind of dirty, grungy beat. Get that to compile and load in the different sample. That's okay. You could make your own samples for anything, speech, a whole lot. And if I wanted, I could alter the speed value, not to be from 0.5 to 1, but to be maybe from -1 to 1, and plot that, just as a finish to a wrap-up. So I grabbed a lot of vocal samples, which are free to use, downloaded from stayonbeat.com.
Angel in the night.
So, you know, huge cheese factor. But there's a couple of interesting things, and when you start distorting them, they start getting very interesting. So I've chosen to load, in this instance, sample number 15, and do exactly the same thing. So I'm going to compile this now. Here's my sample. And as we start speeding it up and slowing it down, we start to get get some proper weirdness. And because I've used, rather than fixed values for dividing my width and my targets and stuff, if I hit the F key, which we put in when we hacked our project templates, I can now make a bouncing ball of sound weirdness, which is just going to do a drunkard's walk through speed and pan and volume. So I've built a really simple drunkard's walk synthesizer that uses the OF sound player object. Next video, I'm going to be investigating some of the artists and designers and musicians who've used techniques like this of randomness and repetition and speed. And we're going to have a look at rebuilding, I think, Music for Airports by Brian Eno in openFrameworks. So hit the subscribe button, leave me comments down below, and I'll see you on the next video. Please. Yeah, that'll do.